Okay. Yes. So we have here a function which is just this one, the f of x equals to x squared minus 6. This is the function. This is the function, right? And we are looking for the value of this function at negative 3 and value of this function at 3 and so on. Okay. And for the new joiners, don't forget to write your full name on the chat. So let's get started with the f of negative 3. Okay, that means we are going to calculate the value of f of x, which is x squared minus 6 at negative 3. So instead of x, because that is the one, that negative 3 is the one, I'm just going to put it instead of x. So I'm going to write negative 3 squared minus 6. Okay, don't forget, when you are squaring a negative number, try to write it inside the bracket, okay, because negative, squaring negative, gonna be not a negative number. It is going to give us a positive 9, because negative 3 times negative 3, and the minus 6. What is that? It is 3. And we are done with this. And the next one is we are calculating the value of the function at 3. So I'm going to do the same, exactly the same thing. I'm going to write this 3 squared minus 6, because this is the value of 3. I will write instead of x, but because it's squared, I'm going to write 3 squared minus 6. That will be 9 minus 6, which will be against 3. So basically this function getting same answer, same output whenever we have 3 and the negative 3. Yes, Ziver, please.
Mister, did you send us preparation questions to Blackboard?
I think I did. Or if I didn't, guys, please, my classes confirm if you get this one or not.
I didn't see any. I just saw the books for like relating to function, but not the test.
Farhan?
Checking it right now.
I am actually too lazy to go.
I found the. Wait a second. Oh no, that's not that one.
Okay, I think I did it. Even I think I wrote an announcement for about
Yeah, I
it.
also got the announcement, but I cannot find it now.
In the announcement, there is a link. You can just put this. I was gonna go and check it out.
Oh yeah. Okay, found it. Yeah,
You
there is
found
the only thing there is just like final exam main topics, but not any like support exam type of question, etc.
topic share, great topic. Topics for foundation topics are shared. Okay, so basically I didn't share it yet. I'll share it right after the session. Okay, right after the session, I'll share it. No worries about it. All right. So for the newcomers, please don't forget to write your name. Okay, just write your full name on the chat. I'll just take the name from them. Yep. They found it at negative 3 and we found it at 3, the function value. And let's just check it for f of 0. Okay, so like I did for negative 3 and the 3, I'll just square this 0 and take away 6. And I'm going to have a negative 6 as an answer, because 0 squared is just the 0. I take away 6 will give us a negative 6. So guys, basically the others are the same. Like you can do it for, I just did this one, so you can do it for the half, f of half, which is gonna give us a quarter take away 6 and some certain value. I'm not gonna do this, but I will do it for the expression, which is f of negative a. Like I did for the numbers, I'll just do exactly the same for the f of negative a. I'm gonna write f of negative a, which is negative a squared. So basically, whenever you substitute negative number instead of the expression, instead of the variable in the function, don't forget to write it in the bracket. Okay, don't forget to write the expression. I mean, the number or expression we are substituting into bracket whenever it's negative. Take away 6. I need to write because x squared is take away 6. So negative a squared will give us just the a squared. Now the negative a squared is just a squared because I'm squaring it. It's going to be positive and the minus 6. And that is the answer. Okay, so you can do it for half, you can do it on your own for the 10. Okay, that's completely up to you. But if you get the idea of for the first question, I'll just move to the second question. But if you have any question, we have the icon there. Just raise your hand if you have any question, please. You have 10 seconds if you have anything to ask me.
No, I totally get it.
Mr. I don't get like the first part, the beginning.
You mean this part? I mean,
Yes.
okay, so this is, if you get the last part, you have to get the first part because they're exactly the same. Negative. I'm just finding, like, we have a general function. This is x squared minus 6. Okay, and I'm calculating the value of this function at 3. I'm sorry, at negative 3. Hamida, at negative 3.
Why?
Means, okay, because that's what they want me to do. Okay, because they're asking for this.
Okay. There is -3.
Just
Okay.
blue negative 3, like this part, like it says calculate the value of function at this indicated points. Okay, at -3, at 3, at 0, half, 10, and negative. That's what I'm doing. Okay.
Yeah. Okay.
Yeah, so that's what I did basically. Square -3 and take away 6, and I found 3. And now is that clear?
Okay. Yeah.
All right,
you.
good job. So no questions. Then I'm just gonna go to the piecewise defined function, and we are also looking for to find out the value of this piecewise function. I wrote here f of x. I don't know why. Like this one is enough. At -2, at -1, at 0, 1, and 2. But guys, different than this function and piecewise function, we're going to work with the cases. Okay, we're going to work with the cases. What it says on the piecewise function, f of x can be two different things, which as you can see over here, it can be x squared, it can behave an x squared, or it can behave as x plus 1, right? X squared or x plus 1, depending on the input values you're giving. Like if you're giving the numbers, if you're giving the inputs less than 0, the function f of x is going to behave like x squared. It's going to be a parabola. Okay, but if you're giving the number, the expression, yes, I'm right, I was right on the first, and numbers and inputs greater than or equals to 0, as you can see over here, the function going to behave like x plus 1. So did you get my point? I think. Are you following me? Clear? Now we're gonna just go to the indicated values. But look, if I'm looking for, it's too bold. Let me just do that. If I'm looking for f of -2, okay, so I need to know where I'm gonna plug this -2 instead of x in the x squared, or instead of x in the x plus 1. Because the condition telling whenever the input we are taking is less than 0, you have to go with the x squared. That means I need to take -2, write it instead of x in the x squared. I need to take this and then square it. And the value that I'm going to get is 4. Okay? If I want to find out f of 2, I did this one, I'm doing this one, f of 2. So I cannot go with the x squared because this x squared works for the negative numbers. I need to go down and I need to check for the second part, which is telling whenever x is greater than or equals to 0, which is 2, basically greater than 0, I'm just going to take this 2 and write down instead of x plus 1. Okay, guys, the function is x plus 1, and instead of x, I wrote 2 in the function, and then 2 plus 1, that I will get 3. All right, so far so good, Hamida, everybody. If you have any question, please do not hesitate. Just immediately ask me.
No, we're good.
You're good. Others, Fatima and Salima.
I understood everything, teacher.
Okay, great job. Good job. What about the other students from the other class? Okay, I have here students that is not from my class. Irana, Ilyas, um,
Everything clear, teacher.
Dilsuz. I hope pronounce your name correctly.
Jesus, yes.
Three students, but supposed to be more than three. Anyway, okay, guys, if it is not clear for you, please feel free. Just open your microphone and let me know. Yes, I'm done. Okay, I'm done. I need to. By the way, this question not ended because I need to find f of -1, f of 0, and f of 1. But because we just keep calculating the same thing, I'm just going to take -1, plug it instead of x squared. I mean x instead of x squared, and find it out. That's why I'm not going to do that. Just not waste the time for this. You can check it out at home for this. Okay, I'll just send this with the solution. All right. Yes. This is the same question. I mean, the same sort of question, like a question 1 and question 2 here. But instead of numbers, they gave a letters like a plus h. Okay, and one more thing that we need to first find out what is f of a and what is f of a plus h, and then we need to work on this different question expression. Okay, so firstly, let's find out what is f of a. F of a would be just the a squared plus 1. Guys, this is not a piecewise defined function. I'm confidently taking a, put it instead of a in the x squared plus 1, instead of x in the x squared plus 1, and that's okay. Okay, that's this expression that I actually got is a squared plus 1, right? This is what I want. And let's just find f of a plus h. Okay, so I'll just take a plus h, which is just together, and write it instead of x squared plus 1, instead of x in the x squared plus 1, which is going to be a plus h squared plus 1. Okay, so what I will do, this is not the end for this question. I just gonna expand a plus h squared. Who wants to help me? Raise your hand if you want. What is a plus h squared? Ziver, sorry, Osman.
So a plus h squared. Should I say this one?
Yes, just only one, that part.
Oh, okay. So it's going to be a square plus 2 ah
Super, and plus
plus h square.
and plus 1. Don't forget the plus 1, and we're done. Okay, no need to do anything because we can't do actually anything. Okay, so the next part of this question, firstly f of a and f of a plus h we did, and the next part of this question telling you find f of a plus h minus f of a divided by h, and we know what is f of a plus h. Ziver said it is just the a squared plus 2ah plus h squared and plus 1. This expression, guys, this whole thing is instead of f of a plus h, and we also know what is f of a, right? I did it as, let me just choose a different color. I did it as, because it's a minus and we're minusing x a squared plus 1, I'll just write it in the bracket for a while. Because of the minus, because we know that minus is going to affect a squared as well as the 1, okay? And divided by h is still there, okay? Not going to do anything with h yet. So then I'm going to keep the first part as a squared plus 2ah and plus h squared plus 1, and this subtract a squared plus 1 as minus a squared minus 1. If this part is not clear for you, why did I write negative a squared and negative 1? Please let me know. I'll just explain you one more time. Divided by h squared. So I'm just gonna then simplify 1 and -1 because they're opposite, they add up to 0, and as well as a squared and the negative a squared will just simplify each other, and we got nothing in terms of a squared or in terms of constant part. So the answer that I left on the top is 2ah plus h squared divided by h. So what I'm going to do next, who wants to help me? What I'm going to do next, this expression can be simplified a little bit further. Aga?
Mr. We will write h and then in brackets 2a plus h.
This process called factorization. We are going to factorize
Yes,
the
factorization.
numerator 2a plus
Then we
h.
will divide h. We will
Uh-huh.
divide h and h will have 2a plus h. Answer.
So I'm just gonna simplify h and h we have on the top and the bottom, and we're gonna have 2a plus h, and that's the answer. So basically, what did I found? What did I find? It's just f of a plus h minus f of a divided by h is just the 2a plus h, and I'm done. Okay, so this whole thing got 3 answers. The one is a squared plus 1, the other one is a squared plus 2ah and plus h squared plus 1, and the last one is just the 2a plus h. Okay, 3 answers for this question, and I'm done. Any question? You have 10 seconds. If you have, I done.
Can you please again explain after when we like Can you please again explain this number? I don't get it so much.
So you mean from the beginning?
No, not from beginning.
From here?
Yes.
Yes, okay. So we separately found what is f of a plus h and what is f of a. We separately found them, right? One is over here, f of a is over here, and f of a plus h is over here. And as you can see, it says f of a plus h minus f of a, which instead of f of a plus h, I wrote the value of it we found, which is just a squared plus 2ah plus h squared plus 1. And instead of f of a, I wrote a in the minus a squared plus 1 in the bracket because of the minus in front of it. And divided by h is just in the expression. I'm just doing this part, by the way. Okay, I done. So far, so good?
Yes.
Until here. Yes. So then I'm just going to keep a squared plus 2ah plus h squared plus 1 as itself, but opening this bracket as negative a squared plus, minus 1. This one, right? And this part also clear, I done?
Yes.
Okay. So then I just started to collect the like terms. Collecting like terms, just simplifying these ones because they're opposite, negative and positive. They simplify each other. And then I got 2ah plus h squared divided by h. Okay, so after simplifying the numerator of this, I'm just right now pointing out with the laser, okay? And I found 2ah plus h squared divided by h. So as I mentioned, 2ah plus h squared can be factorized as h times 2a plus h. Just factorization. It's called in Azerbaijani language vurgularına ayırma. Okay, and I did it. Once I did it, I have a chance to simplify h because I got on the numerator and on the denominator. Okay, so then I got just 2a plus h, and that's the answer.
Okay, thank you so much.
Okay, thank you. Any question? I can see there are some students that haven't turned the camera yet on. Please just keep it on, turn it on, keep it on. Okay. So guys, the important part, this is a very important question. Others was also important, okay? But do these questions, finding the domain and finding the range of function. Firstly, we're gonna stick with the domain, and then we're basically gonna have the question, probably the other pages about the range. Yes, Ziver?
Aren't we just supposed to find where is like x and y, and that's it?
You about the domain?
Yes, domain
Okay,
and range.
just we are going to now discuss it. What is that? Okay, what is this? Okay, just listen. You will understand. Basically, so the idea of finding domain, this is for the domain. Like you are, imagine you are cooking. Ladies, help me cooking what? Help me with the one thing that you cooked recently. I don't know if you cooked anything. I don't
Pasta,
need
macaron.
macaron. Yes, pasta. You cooked pasta, okay, recently. Okay, what ingredient you needed for this? Zivar, let us know. What ingredients?
Tomato paste, cream.
Hot water.
Yeah, basically, we have the ingredient that is for to cook a pasta, right? Otherwise, if you use, I don't know, mm, um, like other stuffs that is not for cooking the tomato, that I mean, cooking the pasta. Have never cooked, if that's why I don't know like what we need, what we don't need. Okay, um, you're not gonna basically cook a pasta, right? So this is true for the domain. You're entering a room and looking for the room is full of the numbers, all irrational, rational, negatives, everything is there, all the number sets, okay? And you are going to choose the numbers from them that you can include this. This is just the pasta. You can include this, but this is x squared plus 1. You can choose anything you want. That I think there is no meal out there like you can choose anything you put it inside. That there's nothing, but anyway, but for the x squared plus 1, you can choose any number you want. Okay, for example, if you want to go with the integers, by the way, domain is the x values. It's just entering the room, choosing the numbers. Is just the number set is called the domain. From that room, which is the domain, you're choosing the numbers. So you're just going there and looking for what numbers I can choose or what numbers I cannot choose. When you enter the room, and you will see I can choose anything I want. Like I can choose any number, and then we guessing that we have infinitely many numbers in the room. Okay, so then what? If we have infinitely many numbers and we can choose anything we want, that means we have infinitely many choices. So that means this x squared plus 1 got the domain as, guess what? Infinitely many numbers, guys, because your options is just infinitely many, and the domain for this is infinitely many x's you can choose. Domain is all the negative numbers, all the positive numbers, the infinitely many thing, okay? Because that is the x squared plus 1, and there is there will be no trouble for us when we choose a negative number. If you choose negative x as a negative 1, x as a negative 1, do you think you will face any problem with x squared plus 1 if x is negative 1? Do you think any problem we will face?
No.
No, because x squared
No.
plus 1 at negative 1 will be 2. No problem we will have there. But what if I choose x as a 1? Do you think we will have any problem with it?
No.
No.
No. But what if I choose x 0.5 or x as square root of 2 or x as, I don't know, 0 or x as negative square root of 2? Will we have any problem when I choose x as negative square root of 2 or 0?
No.
We're definitely not going to have any problem. That is the reason you can choose any number you want for x squared plus 1, and the domain, the options, the numbers, choices you have from the room is infinitely many. That's the reason domain, which is D, is just includes negative infinity to positive infinity. I'm not talking about the range. Range is completely different thing. Just talking about only domain. So the domain for the question 1, which is x squared plus 1, is clear.
Yes.
It's kind of based on the logic. But when it comes to this function, x plus 2 divided by x squared plus 1, unfortunately, we cannot say that we can choose any number we want. We still can choose many numbers, but there is a number or a numbers that we cannot choose it. Okay? Yes, Ilyas?
So here we can also choose any number, but except 1, because denominator cannot be equal to 0.
Perfect. Yes, it is.
Yes.
Because
X1, yes.
whenever we have a fractions, okay, fractions, and we mainly, but basically we mainly not don't care about the numerator whenever it's just the x plus 2, okay, or the something in terms of polynomial. We don't care about the numerator, but what we care is the denominator, because we know we have a problem whenever denominator is 0. Okay, whenever denominator is 0, we're gonna have a problem with this fraction, because we don't know how to divide with fraction yet. Maybe we will know in some days, but still we don't know how to divide with 0. We divide with 0. X squared minus 1, obviously, which is the denominator, cannot be 0. We're all agree with this because we don't know how to divide with 0. That's why we're telling x squared minus 1 cannot be 0. Are you okay with that?
Yeah.
And x squared minus 1 cannot be 0, and that means x squared, it cannot be 1, but because it is the squared, because it is the squared, Elias said the one answer for this. We have two answers, so basically we're gonna tell x squared cannot be
Plus and minus.
positive and negative 1, because the square of negative 1 is also 1, and 1 take away 1 will still be gonna be 0. So basically we're gonna tell that domain can be anything. Domain can be anything. You can choose any x's, but apart from 1 and negative 1. But how I'm gonna demonstrate on the interval form. So I'll just demonstrate it like that. Negative infinity to negative 1. I'm using the open bracket for the negative part, negative 1, because I'm telling non-including. And guess the other part. Aga, you have an idea for the other part?
No, I have just one question. Like, we can't also take -2, no? Because if we will put it
Why-
instead
why-
of x, it will be 0.
It will be 0 on the numerator,
Yes, on the numerator.
but not on the denominator. And we know how to divide 0 by any number, right? 0 divided by 4 would be
0.
0. That means you know how to divide it, but we don't know how to divide by 0, not 0 by number.
Okay.
Okay? Yes, negative infinity to negative 1, I've done this part, okay? I'm looking for the other part. Aytash, help us.
We should write union then from 1 to positive infinity.
From 1 to positive infinity, that is the correct part, but we have between these two, we have another solutions. We have another numbers that work for this, okay? It is also between, it's also between negative 1 and the 1, okay? Because, so 0 works for this, right? If I choose only negative infinity to negative 1 and 1 to positive infinity, that means I'm not including 0 as a domain. Agree with me? 0 isn't in this domain, but 0 does work for this function. If you put instead of x0, you will get negative 2 as an input. This function gonna produce negative 2 whenever x is 0. That's the answer, and we found it. That means 0 is also included domain. That means I'm going to include the numbers also between negative 1 and 1 to this domain. And by the way, between negative 1 and 1, we have infinitely many numbers. Okay, infinitely many numbers between negative 1 and 1. And we also need to include this. And this is the written form for the domain of this function. So obviously, let me just save this thing, and then Ophelia, you're back to your question. Whenever we have a polynomial equation, you've been over polynomial expressions, right? For example, x squared plus 1, or you can have here, I don't know, x squared plus 2x plus 1. Domain of these polynomial functions always going to be negative infinity to positive infinity. But when you have a irrational expressions like x plus 2 divided by x squared minus 1, like that, Okay, like that. Guys, mainly pay attention to the denominator, because the only problem we can have whenever denominator is 0. Pay attention to this part and take it different at 0 and then solve this. And what about the thirds, like square root of x squared minus 9? Ophelia, your question?
Teacher, why can't we just take from negative infinity to negative 1 and union from 1 to positive infinity as an answer?
Okay, if you take the answer as negative infinity to negative 1 and 1 to positive infinity, okay,
Yes.
Ophelia, you are going to have a problem. I mean, you are going to, like, sorry for just kind of distract for a while. Okay, you are not going to include, for example, 0.5 as a solution, as a domain, okay, for this expression. Agree, Ophelia? This
Yes, like
0.5,
decimal numbers.
no, not decimal numbers. So if you just take the answer as negative infinity to negative 1 and the 1 to positive infinity, Ophelia, that means you are not including, for this solution, guys, forget this part, for this solution only, I'm just pointing out, you're not including 0.5. Agree, Ophelia?
Yes.
But 0.5 works for this expression. Agree? For this 0.5 is the that means x can be 0.5 for this expression. It works for this, but you're not including it over here. That's why I'm telling those stuffs like 0.5 or negative 0.5 or 0 or 0.01 are the numbers that work over here, right? And let's just include them as well. But since they're between negative 1 and 1, and I'm just going to take the set as negative 1 and 1 and include it over here. That is the thing that I've done.
Yeah, I understood. Thank you.
That's the reason, because 0 also works for this. But if I took only this one, I'm not including 0 to the domain of this, but it is working for this. That means I need to take this like a bit general to include the others. All right?
Yeah.
But when it comes to g of x equals to square root of x squared minus 9, okay? Okay, so we're gonna think about the problems first, okay? Since we are talking about the domain is this expression, x squared minus 9. We're gonna think about like that. Okay, x squared minus 9 can cause any problem with the square root. Okay, so far we know that under square root, negative number cannot be. Okay, we don't know what is the square root of negative 2 yet, right? We don't know what is it yet. So basically, we cannot have a negative number under square root. So, but it's for the square root. It's not for the cube root. Okay, it's for the square root. It's the root. It's for the roots with the even power. Let's say if we have here fourth roots of this one is also true for this. Okay, square root. So that means we're gonna tell, okay, so whatever that x squared minus 9 is supposed to be greater than 0, but also can be 0 because under square root 0 is defined, which is just a 0. And we have in here expression. We found that x squared minus 9 supposed to be greater than equals to 0 in order to this function like behave properly, let's say. Okay. So we have here inequality now, and we are looking for the set for the x's, right? And we have here inequality, which is x squared minus 9 greater than equals to 0. And I want to find out what is that x's make this x squared plus minus 9 greater than 0. So in order to solve this inequality, I'll just factorize this as, who wants to help me with the factorization of x squared minus 9? X squared minus 9 will be factorized as what? Osman?
X minus 3 and x plus 3.
Yes, good job. Osman, then I'm going to sketch a number line and find out the roots for x minus 3 and x plus 3. What are the roots if they're equal to 0? It is negative 3 and the 3. I'm just going to include both of them, negative 3 and 3, because I'm telling here greater than equals to. Then you know better than me, we're going to use this one and choose a number greater than 3. Okay, number greater than 3, if I choose 4, so and plug it instead of x in this expression, 4 squared minus 9 would be 16 minus 9, which is the number greater than 0. That means this part will be greater than 0. And then it changes always positive, negative, and positive. Actually depends on the question, change like that. Okay, so the solution that I'm looking for, the expression is positive, like this part, this is the solution part, and this is the solution part. Basically, whenever we're gonna take just the x's from negative infinity to 0, union with 3, negative infinity to 3, negative 3, and 3 to positive infinity. Okay, all x squared minus 9 would be greater than 0 whenever I choose x's in this interval. Okay, Osman.
Mr. Al, why is there square bracket, no square bracket, it's circle brackets like?
No, yeah, so you are absolutely right. I have to use the square bracket because I'm including, because I'm including 3 and negative 3. Yes, thank you for pointing that out. Because I said here, I need to include it. Yes, square bracket, because both negative 3 and 3 can be the solution for this. Any questions so far for the domain, guys? You are going to see a question require domain as well as the require is range requirements. 2 requirements you have, a domain and range for the question. Well, we are doing domain and we will do the range. Okay, if you don't have any questions so far, so we are on the question 4, and I think I'm not going to do question 5. Okay, actually, like, question 5 is very easy. Like, I just want to use sync on it. It's just the word problem looks weird, but it's not actually. It's just the value of VC. You're just gonna put it instead of VC and find it out. This is the this is the light theory of relativity. Like physics, you may see this, or you will see this equation next year on your physics lesson, and this substitution, that's all about the substitution. That's why I'm not going to do this, and this is going to be the last question. Last question. We have 12 minutes, 6 and then 7, and that's it, last question, and then we will keep going the next questions next day. So sketch the graph of the function by first making the table of the values. What is this? We're first going to make the table of the values. We don't have negative part, unfortunately. We're going to have only positive numbers, I think. Yes, we're going to firstly complete the table. Okay, completing the table is also about the substitution, because it says what is the value of the function x squared minus 4 at negative 3. What is it? Who wants to tell me? Yes, Ilyas?
Yes, we should write y equal minus 9 minus 4, yes?
Yes,
we should change x with y, yes?
It will be, yes. It will be 5 then, right?
Yes, 5, yeah.
So basically at negative 3, the function produce 5. But what about at negative 4, at negative 2, Hamida? At negative 2, Hamida. Hamida, are you here?
Yes.
At negative 2, x squared minus 4 would be?
4.
Okay, so at negative 2, x squared minus 4 would be?
0.
Would be 0. Very well. Thank you. Aidan, at negative 1, it would be? At negative 1?
3.
It would be, no. Negative 1 squared minus 4 would be negative 1 squared minus 4.
-3.
Minus 3. Thank you. Rehana, at 0, it would be,
0 minus 4.
what is it?
In 0, it's -4.
At 0, it is minus 4. But what about Dilsus? What about 1? At 1, it would be
-3.
good job. At 2, Celia, at 2, it would be, Celia, are you here?
Yes, mister.
At 2, it would be what?
It will be -2.
At 2, it would be -2. Are you sure? Think about it one more time.
0.
It would be 0. Irana, at 3, it would be, Irana. Irana, at 3, it would, at 2, at 3, it would be, at 3. Irana. Salima, at 3, it would be, Salima.
Yes, it will be 5.
It will be 5, yes. Guys, I put here a coordinate system, xy plane, but we don't have a negative part for this coordinate system, as you can see. That's why we're gonna maybe have a little bit problem while we're sketching this, okay? But no worries. Let's just go and work with the positive numbers then. At 0 now, okay? So basically, I have to. I'll just take this coordinate system and instead just write a normal one. Okay, basically, if I want to sketch it, let me just open this. Okay, if I want to sketch it after completing my table, I'll just do this and I'll just do this, and I need to number, like, let's say this is 1, this is 2, this is 3, this is 4, this is 5, and then -1 and -2, -2, and then I'm sorry, and then this is going to be -3, and then this is going to be -4, and 1, 2, 3, 4, okay, and then -1, -2, -3, -4, -5, just writing. Okay, as you can see, at -3, whenever x is, where's the options here? Okay, at -3, the function getting 5. Okay, so I need to go one more up. Function getting 5. We are basically talking about this point. Okay, so then at -2, function getting 0. That means we have an intersection over here. It is this point. At -1, it gets -3. That means we are talking about this point. You know how to work with the coordinates, right? So then at 0, whenever x is 0, getting -4, that means we have their intersection. At 0, it gets, at 1, it gets -3. That means we have a turning point somewhere here, you will see. And at 2, it gets 0. That means we have intersection. And at 3, it gets 5. At 3, it gets 5. Basically, we're talking about that point. So the next step is to connect this, but since this is the x squared, you got to be careful that is the parabola, not the line. And I sketch it very roughly, but anyway, so your graph you want to sketch is something like that. Okay, let me make it a little bit bigger. Okay, so it is the graph of x squared -4. Okay, so since it's the parabola, I cannot sketch exactly line, like straight line. I need to make it a little bit curvy, right? Like a little bit curvy. Okay, but because we're sketching by the hand, that's okay, but try to show it's a curve and not a straight line. Remember, your last exam, I'll deduct the points because you just sketched the parabola like a straight line. Okay, that's the reason. And okay, basically, If you're trying to sketch the piecewise defined function, by the way, do you have any question regarding that? I mean, I forgot to ask question 6.
No.
No question. Amazing.
How are we supposed to draw it on the graph? Like after we find the numbers?
Yes, because it's a sketch the graph. Okay, it's a sketch the graph. So, but for the piecewise function, it's a bit different because piecewise function got 2 different equation depending on the input. So the first one is the f of x equals to 2. The other one is f of x equals to x squared. So my suggestion for you is to always go ahead to learn the general graphs. If you have get it, I don't know, I just added a quick notes for the finals from the function. We have a table of graphs. For example, x cubed, graph of x cubed, x squared. And you got to know that the graph of x squared, just roughly speaking, is just something like that. Okay? And this is the graph of, everybody knows that this is the graph of x squared. I don't need to create a table. I don't need to find out the coordinates. Just what do I know? It's the graph of x squared. I'm just gonna put it over here, and that's the graph for me. Okay, and just I'm still not dealing with the piecewise, but I'm sketching x squared, and as well as I have one more graph here, f of x equals to 2, and you need to know that f of x equals to 2 is the horizontal line parallel to x-axis, okay, passing through the 2, and I'm talking about this line. Can you see these graphs, that lines that I've drove on the xy plane? Can you see that, right? Parabola and the horizontal line. So the next step is to, guys, basically cut off the parts that doesn't work for this piecewise function, because we know that our piecewise function behaves like 2, which is just this one, right? Behaves like 2 whenever x is less than or equals to -1. So firstly, I'm just going to take, okay, this is the -1 axis, and the function going to behaves like that whenever I'm dealing with this domain, with this part. That means I need to delete the part that I've sketched for the positive, okay, until here. Okay, one more time, because the function given, like whenever the x value is less than -2, the piecewise function behaves like 2. On this domain, it behaves like 2, and that part is works. I'm not going to take this part because it's the greater than -1 part. But the second part of this question is telling you it behaves like x squared whenever x is greater than -1. Obviously, parabola right now I sketch is just got both of the parts, and I'm going to delete the part that I don't need. Oopsie, I just deleted. Okay, until what? Until the -1. Okay, so I'm also going to delete this red line. Oh, I didn't mean it. Let's get it a little bit. Yes. Okay. So and I'm going to fill this, and I'm going to fill this. I'm going to include this, but I'm going to take an empty circle for this part because I'm not going to include it. Otherwise, that's not going to be a function. Okay, a function can get one input, one output for one input. Okay, so basically, this is the graph of the piecewise function that I've been over. Okay, this is the graph of the piecewise function. This branch and this branch we got. Understood? What did I do? If it is not clear for you, feel free to ask me. Okay, feel free to ask me. I'll just explain it one more time. If it is clear for you, you are you're good. Farid, please. Farida, sorry, Farida, sorry.
Yeah, could you please explain it again?
Okay. So one more time explaining it. Everybody listen, you may need it. Firstly, my suggestion, Farida, is for you to know the graph of f of x equals to 2. If you know this graph and sketch it, whole thing, just forget about this part for a while. Sketch the graph of f of x equals to 2. If I sketch f of x equals to 2, I'm just going to have this graph. Okay, it's a horizontal line passing through the 2. And as well as you need to know the graph of x squared. And there is a table and this literally telling you the graph of general functions like in x squared, x cubed, square root of x, cube root of x, and so on. And if I sketch it, it will be something like that. Okay, x squared. Then I'm going to go with the conditions. Then I'm going to go the cases. Firstly, first case, Farida. It says f of x behaves like 2 when x is less than -1. So x is less than -1 is this part. I'm just pointing with my laser. Can you see this? I'm talking about this part. This part is the inputs where x less than or equals to -1. And the corresponding part for the graph of the graph is this part for this, right? Because it's talking about, we are talking about 2 is this part. Agree?
Yeah.
Yes. Basically, if this part works for this domain and we cannot take the other part, that means we cannot take the positive part because we said that this function behave like f of x equals to 2 for the inputs less than equals to -1. That means this part works for this. And if you look at the second condition, second case, you will see that it behaves like x squared whenever x is greater than -1. Behave like x squared whenever. Okay, x greater than -1. I hope you agree with me. We are talking about this domain, right, Farida?
Yes.
Yes. So for this domain, basically, it's talking about the parabola, but we're going to take that part of the parabola because we can only give that inputs. It's going to produce the parabola. We cannot take this part because it's not included for the parabola, right? It's just for this one, for the f of x equals to 2. Well, after sketching and just cutting off the not necessary parts, the parts that we're not going to deal, we're going to left over this graph, and that's the graph of piecewise function. And the one more important thing that I'm not including this because it says greater than -1. That means at -1 you cannot have a 1 value, but at -1 you have value 2, as you can see over here. That's why I'm including this part. It's just filling the circle. That means included, but not including this part. Okay, Farida?
Yes. Same.
Okay. Sketching piecewise functions a little bit hard, I understand, but it is if you just work on it, you will see it's actually easier than you thought. Okay. Well, everybody, one more thing. You gotta turn the camera on. Everybody needs to do that. Okay. Everybody need to do that. That's important. I'm just gonna take a picture. Turn the camera on. Everybody. And not show the, I don't know, the roof or the wall. I'm not interested in with it. Your face. Okay. Reyhana, Gültekin, Aytaç, Malik, Aslan, Leyla, Ophelia. Hurry up. Hurry up. Otherwise, I'll not let you go. I will not let you go. Thank you, Hamida. Gültekin. Well, curtain. I like that, but wanna see you. Nigar, Irana. Thank you, Rehana. Aslan, still waiting for you. Thank you, Leila. Looks like you just woke up. Nigar, Irana, oy dada. Okay. Sorry. Sorry. Malik Akhundov, last call. And Aslan, last call. And I'm going to remove them.
Yes, teacher, I'm sorry for. I have bad connection.
You gotta turn the camera on if you can, or I'm just gonna remove you from the session. You have two
Okay.
options.
Okay, can you give me please 1 minute?
Okay, 1 minute more. 10 seconds, please. Yes. Okay. 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 Okay, I just took the picture that I need. Thank you so much for joining the session. Thank you so much for joining the session. Have a great day. See you tomorrow at the same time. Okay?
Bye, Mr.
Mr.
Have a good day.
Or maybe at 9 o'clock. Okay, 9 o'clock. Have a great day.
Have a good day.
See you.
Tomorrow
Bye.
will be online.
Wait, 9 o'clock? What?
Yeah.
Isn't it 11:30?
No, tomorrow you have an exam,
Yeah.
right?
Yes.
And I
Yeah.
can